Okay, at 7.3, we are talking about triangle similarity. So similar, we learned already, is when two polygons are the same shape, not necessarily the same size. So today we're only talking about triangles, and we're going to prove or use three similarity postulates: angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So what do those mean? Angle-angle similarity, and I think you remember this. The sign for similarity is this little tilde. That means similar. So instead of writing angle-angle similarity, we could just write this as a similarity. That's when we know we have two angles in triangles and in two different triangles. And if we know that one set of angle is congruent to another the corresponding angle, and another set of corresponding angles are congruent, then those triangles will be similar. So we don't need to know anything about their side lengths. As long as we know about two angles, then those triangles are going to be similar. Side-side-side similarity doesn't mean that the sides are going to be congruent, but they're going to be similar. So I'm going to put a little tilde. So this side is similar to this side is similar to this side, and this side is similar to this side. Then we know that those triangles are going to be similar. So this one's kind of the opposite of angle-angle similarity. In angle-angle, we don't know anything about the sides, but we know just about the angles. And side-side-side, we know about all the sides, but nothing about the angles. And again, the triangles are going to be similar. So what could that look like? That could look like, I could tell you using tick marks like this. I could also write it out with a proportion. So for example, I could say side length AB is over AD is equal to side length AE over DF. Those are the green sides. Here's AE. Oh no, sorry, that's AC and DF. My bad. AC. And it's also equal to the blue sides, BC over EF. So this is another way I can show you in writing that the sides are similar or proportional. Right? Okay, same thing. So we have angle, angle, side, 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 and the last one is side, angle, side similarity. And this one should also be familiar because it's a congruency postulate. So side, angle, side, again, we know about two sides and that included angle. Remember, this angle needs to be touching both of those sides. That's called the included angle. Okay, so we need to know, again, angles are congruent, so that's important, and those sides are not congruent, but are similar. So, example, this one's similar to this one, and this side BC is similar to this side EF. Then we know that the triangles are similar. Okay, so what I want you to do is I'm going to go on and do some more problems, but I want you to come back, and I need you to write in your own words what you think that angle-angle similarity, side-to-side similarity, and side-angle-side similarity mean. In your own words. Super important because that's what it says over here, in your own words. And we're going to discuss this with your partners tomorrow or the next day. Okay, so example, how we're going to use this stuff. It says verify the triangles are similar. So verify means prove to me that they are similar. So for example, in number 1, we have two right triangles, sweet. And then we have these angles, and these angles don't look to be congruent to me. So at first guess, I might think, okay, that these triangles are not similar. However, look for the third angle. We know in triangles that the angles add up to be 180 degrees. And when there's 90, that means that these two other acute angles have to add up to be 90 degrees. So what I can do is I could say, okay, well, 90 minus 43, let's see, that gets me 47 degrees. So that means this angle has to be 47. And if you weren't sure if I did this right, you can check. 47 plus 43 plus 90, does that equal 180? And by golly, it does. So if you look over here, what do you think this angle is going to be? Well, it has to be 43 degrees because, again, 43 plus 47 plus 90 equals 180 degrees. So since all the angles are congruent, we know that these triangles are similar. So I can write a by angle-angle similarity. So I know that they're similar by angle-angle similarity. So I can write a sentence by angle-angle similarity, comma, triangle ABC is similar to triangle, let's see, A looks like D, so D, B looks like E, E, and then C is that last one, and C was congruent to F. So remember this is called a similarity statement, and it needs to, the angles need to correspond. Okay, so that's kind of the process that you're doing. You're telling me how they're similar and then write a similarity statement. For example, in number 2, it looks like it's side, side, side because they don't tell us anything about the angles. So I'm going to assume it's by side, side, side similarity. To check it, though, I need to make sure that they're proportional. So for example, this shortest side, 2, should be similar to this shortest side, 3. And then the rest of them are the same. So I could write it again if I want to, but I know that the other one's exactly the same. So what you can do is use a calculator. 2 divided by 3 is 0.66 repeating. If you put 3 divided by 4.5, do you also get 0.66? If you do, then they're similar. If you don't, then they're not similar. So that's something for you to check. So you're going to try to do number 3 and number 4. Again, check to make sure that the sides are proportional if that's what they give you. Then tell me how they're similar by either AA, SSS, or SAS, and then write the similarity statement. Okay, and then I want you to think about this reflection. Why are ASA and AAS not similarity theorems? That's a good question. We'll definitely go over that tomorrow. Okay, last thing we're going to do, example 3, finding lengths in similar triangles. Verify the triangles are similar and then find the missing lengths. So first question we need to do, are the triangles similar? If so, how do we know? Well, let's see. In this one, they talk about sides and angles, but since they don't give us x, we can't use side angle side. So let's see, and they don't tell us about all the sides, so that means that it has to be angle angle. But where is that second set of congruent angles? We have one set right here. Well, let's look at the triangles that we're comparing. We're comparing this little triangle with this big triangle. So what I'm going to do is sometimes it helps if I redraw it. So I'm going to redraw ACD so we don't get confused. Okay, and I know this is a right angle. And let's see. So we both have right angles. That's one set. And see how they both have angle A? Well, they're congruent. Triangle AEB and triangle ACD are similar, excuse me, by angle angle. Yes, by angle angle similarity, they are similar. So cool. Now that they're similar, go ahead and find the missing length. So we want to solve for x. All right, well, we can set up a proportion. I know that inside, and for triangle AEB, the side lengths are 5/9, so I can set that up with these ones. And it looks like it would be x over 3, but it's not. We know that this whole side length is x, but how long is all of AC? AC is 9 plus 3, so that's 12. So I know 5/9 corresponds with x over 12. And then I cross multiply and solve. 5 times 12 is going to equal 9 times x. 5 times 12 is 60 equals 9x. And then all I have to do is divide by 9. And you can leave this as a decimal or a fraction. I'm going to leave it as a fraction since I don't have a calculator with me. All right, so you're going to try to do that number 6. Number 6 is really tricky. I'll go ahead and do this one with you. It says find the side length of RT. So we want to know how long this is. I'm going to call RTX. Okay, last one, promise. All right, well, first of all, are the triangles similar? We have one set of angles. They don't tell us about all the sides, so it can't be SAS or SSS because we don't know how long this side length is. So it's got to be angle-angle similarity. And again, it helps sometimes if you redraw this triangle. So I'm comparing this little triangle, RSV, to the huge triangle, the big triangle, RTU. So this one will be RTU. And I know that angle T is congruent to angle S, but see how they also share angle R? So I know that they're similar by angle-angle similarity. Now I can figure out how long side length RT is. How long is RT? Okay. Well, let's see. In this smaller triangle, RSV, I know I have side lengths 10/8. So I can compare that with, let's see, 10 looks like side length RT. And let's see, so I could put RT here. And I know that these two sides, 8 and 12, correspond. So then I can just cross multiply and solve. So 10 times 12 equals 8 times RT. So 120 equals 8 RT. And then divide both sides by 8. And so RT equals whatever 120 divided by 8 is. That's not the hardest question I could give you. We can talk, remind me to talk about tomorrow in class how we can solve for just this part if we want to. And we're also going to do the proofs. Yay. And don't worry about reflection number 2. We haven't talked about concave and convex polygons. So it looks like, let's see, you can try the math humor and finish those other problems I asked you to do. Fun fact of the video. Let's see. Oh yeah. One man dribbled a basketball for 230 miles. 230 miles to raise money for Japanese tsunami victims. 230 miles. That's like dribbling all the way to San Diego and then back. It's pretty impressive. All right, similar triangles. You guys are good to go.